Hi, today I want to share with you the electrical wiring for this house, the way I designed it. So in this project I have taken care of all electrical codes of India. All the electrical codes were taken care. So these are the codes which I have complied to: National Electrical Code of India, Bureau of Indian Standards Guidelines, Section 732, National Building Code of India, Central Public Works Department General Specification for Electrical Works. And from this book I have taken some important information. This is Electrician First Year Volume 2 of 2 Trade Theory. This is ITI book. Okay. So these are some of the rules and regulations which govern electrical installations in India. Okay. So this is the house. This is the subject of our discussion. This is the main room. This is the main door, drawing room, bar area, internal corridor, dining, kitchen, maid's room, servant's room, utility, common balcony, master bedroom, attached bath, dresser, children bedroom, toilet, children bedroom, balcony, toilet, guest bedroom, and their bath cum toilet. So once we have received the diagram from the in AutoCAD, we developed this room. We have placed the windows, everything, and we have put textures. We have rendered the lighting. We have checked the lux levels, and I mean, for every room there is a different intensity. Not all rooms are the same, as you know. So the lighting lux for the kitchen is 100% different from that of a bedroom. In fact, the CCT is different. This is 4000 Kelvin, this is 3000 Kelvin. Okay. So as per those guidelines we have done this design. Now this is just the beginning. After giving the light points, this is not the only thing in a house. There are several other equipment that you might want to learn. There is TV, there is AC, there is geyser, there is micro oven, there is stove. Then you might want to have several utility ports where you want to charge your phone, okay, etc., etc. So this is the house. We'll keep it like this. So we'll have it as a reference. And this is the wiring. This is the wiring for this. So this is the entire floor. This is the entire floor. And these are the lights which we have placed in that DIALux lights. So this is L1. So these are the codes for the lights. So we have finished wiring this house. So this is a highly detailed work, and this is a purely engineering work. This is not some random work that some electrical guy comes and pulls a wire. This is not that. This is highly technical thing. So let us first come to the master bedroom. So in the master bedroom I have given switchboards on either sides of the bed. This is for the equipment, because nowadays people tend to use many electronic equipment like sleeping aids for snoring. CBAP machine is there. Then then what is that, some massage kind of an equipment comes under the bed, and there are several other equipments. So it can be used for those, or it can be used for charging the phone, or it can be used for lighting a lamp. So these are the symbols. These are the Indian symbols. As per Indian electricity code, this is a 6 amps switch, and this is a socket. This is a normal socket or simple socket. In Indian terminology, this is called a simple socket, and this is a 6 amperes switch. This is the main switch box for the bedroom, which is placed here. Again, there is a standard at what height this switch box has to be placed. There is a standard. They can't be placed as and where you like. There is a strict code for this. The bottom part of the switch box has to be at a height of 1.3 meter from finished floor level, and this is the what is this called? This is the door frame. From the door frame, the gang box side has to be at a distance of 0.1 meter. And if you are placing another AC switch, then that switch has to be in a separate box, because never ever should you run the utility lines and power lines in the same line. Otherwise, if the project goes for inspection down the line, if a competent authority comes and inspects it, then that will be void. He will ask you to redo. So never ever do that. This is a separate line, this is a separate line. Okay, either ways. So this is our main switch box, main switch board. This is switch number 1, 2, 3, 4, 5, 6, 7, 8. Switch number 1 is controlling these 6 downlights, these 6 downlights. Switch number 1 controls, and switch number 2 controls AC. Now you might say, how can a small 6 ampere switch control an AC? How is it possible? No, it is not possible. But yes, it is possible in this case, because this is a VRF system. This is a VRF system wherein there is only one outdoor unit for this system. That will be placed here. My outdoor unit will come here. This will be a 10 HP outdoor unit, and there are 6 cassettes in this. There is 1, 2, 3, 4, 5, 6. There are 6 cassettes. Okay, so this switch is basically controlling only the this particular indoor unit. This indoor unit has what in it? It has an evaporator. Okay. Then there is throttle valve in it. There is one small throttle valve, there is one evaporator, and there is a fan. How much wattage will the fan draw? Hardly 60 watts or 80 watts. So that is the reason, that is the science behind this, why I have used a 6 amperes switch to control this indoor unit. This is a 1.5 TR, this thing. Okay. Then this is a fan regulator. This is a fan regulator, and this occupies 2 spaces. So this is 2 modular, and this switch is controlling this regulator, and from the regulator, as you can see, this is more of a concern of the electrician, goes to the fan. Again, one more thing, as per National Electrical Code, this is the symbol for the fan is like this only. In our ITI textbook, second year, Babu, only this is the symbol of the fan. Why I have drawn this line? This line I have drawn. I have taken the help of this line to see if any light is falling under this. That is the reason why I have done this. Okay. Then okay, this is the symbol for what? As per our ITI book, this is the symbol for exhaust fan symbol. These are the standard symbols. So then this switch I have given as a spare, and this one blank, I have given a blank. So down the line, what happens nowadays, people are going for a lot of curves and design profile lights and all that. They might place a profile in this cabin, under the cabinet lighting and all that. So for that, scalability has to be there. That is the reason why I have given one spare switch, then 2 blanks. I give one spare and one blank, but by the virtue of this this board, this has to be 8 modular, 6 modular, 10 modular, 12 modular, na? So that is the reason I had to give 2 blanks here. Okay, so generally I give one switch and one blank. That is a standard engineering practice. and to this so the incomer, this is a 1.5 square mm wire which is coming from R1. This is coming from R1, DB R1 lighting, master bedroom, master bedroom main switchboard. It comes from here. R1 from this to 1.5 square wire is going. What is this? This is our DB 12A TPN per phase isolation PPI distribution board. This is all these calculations. This will be done by the engineer. If you go with an electrician, he will give you something and it will be I don't know. Down the line, it will cause issues because there is a short circuit analysis. You can't place any MCB, all that thing. Okay, let us get back to this. So this AC, what does an AC indoor unit have? It has a liquid line and a suction line. Suction line will discharge the refrigerant to the compressor. Compressor is placed here. Okay. Liquid line. Okay. Refrigerant is coming from this. Refrigerant is entering through this to the evaporator, and from here it is going to the compressor for recirculation. This is the water discharge. Because of condensation, the water is formed. The water has to be removed. We'll have to draw it like that. So down the line, there might be maintenance issues for this AC. So 100% wherever there is an AC, just beside it, it is their standard practice to give a 2 feet by 2 feet service trap. 100% this has to be there, because down the line, if any issue comes, this whole ceiling has to be broken, false ceiling. Okay, this light has to be moved. That is okay, we'll do it later. So that is the reason we have placed it here. And this is what? This is a curtain pelmet. Nowadays, people are opting for automation. So in the automation, they can control curtains also. There are two. One is shear and one is blackout. So for both, we'll have two motors. No, if they operate one motor, then the shear will open and close. If they operate the other motor, the blackout will operate and close. For that sake, I have given two 6 amperes 2-pin sockets here, because generally the motor, those curtain motors, they are imported from China. They come with a 2-pin plug. So we have provided for those also. Okay. And what else is there in this? Every room as per our Indian standard, every room shall be provided with a 16 ampere socket. This socket will be used for vacuuming, cleaning, ironing or any other activity. So one socket you have to provide. This is a standard. So the socket height is 1.3, switch height is 1.3 meter. Socket height is 1 feet from finished floor level. Most of the people, they will put these two together at the floor at 0.3 meter, but this is wrong. You cannot put it like that, because if there are small kids in the house, they will put a finger or a metal in this socket and he will turn on the switch. So this is, you should never ever put a socket, and you should never ever put a switch for this power socket just beside it. The switch has to be at 1.3 meter high. Socket has to be at this side. That is only for this one. Let us say if this is a computer socket, these are for computer, the height could be different. This could be around 1.05 meter height. So this box is at 1.05 meter high. Okay. So this is a dresser. In the dresser, people walk like this. On the right hand side, there is a switch and a blank. Turn on the switch, this light lights up. You come forward, and here we have something interesting. We have a light behind the mirror. This is the light behind the mirror, we can assume. Then this is the switch controlling that. We have a blank, and we have two sockets, because they will run hair iron, hair drying machine, and several makeup machines are there. So those activity will be done here, so that has to be provided there. This is for the bathroom. one switch for the downlights, 6 downlights. Second switch is for the exhaust fan. So this exhaust fan here I have said ACH is equal to 20. That is air changes per hour. These are air changes per hour. As per National Building Code NBC, ACH is 12. It can't be below 12. So I have calculated this volume. Based on this volume and based on the this air delivery, this value is calculated. This is coming out to be 20. So this is adequate. This fixture, this fan which I have designed for this one is proper. And again, inside the bathroom, you have to provide one mirror. There has to be light behind that mirror. And here what I have given, this switch, the first switch, this is the first switch, 1 2 3 1 2 3. If you are looking at the switch, you are facing it, you are standing here and you are looking at the switchboard. No, or you are standing in front of the switchboard and you are looking at it. Then this is switch number 1, switch number 2, switch number 3. Okay, switch number 1 operates light, switch number 2 operates this socket. This is 2 pin, because in the bathroom 2 pin is more than sufficient for the trimming. Okay, brush, what is that? Brush, brushing, electric brush. One more is provided here. Okay, and these boxes they shall be placed at a distance of 2 feet away from the tap or the nearest tap position. So this is for one room. Then this is the second bedroom. Even in this room pretty much they are the same thing. We have the same provisions. One switch number 1 is will control the lighting. Switch number 2 is for the AC. This switch number 2, this one, this is for the AC. And here switch number 3 is for 2 pin power. Then this is a spare, this is a blank. Then there is a fan regulator here, fan regulator switch to control this fan. Fan should be placed at a particular place from this one. The AC has to be placed at a particular distance from the bed. Those were taken into consideration. Then again, beside the beds there has to be provision, because people, like I said, they will use CBAP machines, nebulizer, CBAP, BP machines, electric, other medical equipment they will use. So these has to be there. And a better engineering practice is not to hard code light for this, because most of the designers, what they will do, they will give a light. That means this switch is 100% fixed to that light only. Down the line, if the client wants to put a phone charger in this socket, then here he wants to have his CBAP machine for sleep or body massager or some other machine, then there is no scope. So this is a superior design. If he wants a light, he can always plug in a light in this. So this is much versatile. This is more versatile. Then here there is a box for this. This is for the geyser. Bathrooms. So let me explain you the kitchen. So the kitchen is a place where there will be an n number of sockets. There is fridge, there is electrical chimney, electrical stove, electric rice cooker, electrical kettle or water heater, air fryer, convection oven, micro oven, mixer grinder, blender, toaster, sandwich maker, RO unit, food waste crusher, disposer. So we have to provide provisions for all of these. So this is the main switchboard. 1 is controlling the switch, 2 is controlling nothing, 2 is spare, 3 is blank. Then here I have provided a point for microwave. This is worktop board 1. There are 2 power sockets here, 16 amp sockets. These are 16 amp sockets. Then again coming here I have given 2 more. Then coming here I have given 2 more. Then this is for the electrical stove. This is going to whiten. This is what? This is for the chimney. and this is for the food waste crusher. That is there is a machine that comes under this sink that crushes the food and disposes it. Then there is the RO unit here, there is a fridge here, there is a trap door here. So coming to the dining area again, dining area I have 6 lights. Switch number 1 controlling those 6 lights. Switch number 2, what did I do with switch number 2? Okay, this is the AC for this. This AC is for this dining area. Okay, switch number 2 is going to AC. Switch number 3 is going to your trap door. In fact, this trapdoor should not be placed here. This trapdoor should be moved here, because this trapdoor should be moved here, not here, because we want to be able to maintain the ACs down the line. There might be leak, there might be any problem. So what I did, from this switch a circuit goes into this. Okay, and this is the DC wiring for this. This is the cove, this is the cove, this is the cove. Okay, let me show you this dining area. In my dining area, what do I have? So this is the dining area, na? I have placed a switchboard here. Okay, switchboard is here. In the diagram I am showing the trapdoor as here, but it has to be somewhere around here. It has to be here. Okay, so from this switchboard I will draw a from this switchboard I will draw a wire to this trapdoor. I will place the CV driver here for these coves. Okay, for these coves it will be placed there, and from there DC wire comes to this. Okay, and here what we have a pelmet. I mean, in this diagram we don't have, but here we will have a pelmet. Then there are curtain motors here. Okay, there will be curtain motors here. As you can see, there is a pelmet here. There are 2 curtain motors, as I explained before. Then this box is for the balcony. This box is for the balcony. This switchboard is for balcony. Okay, this is for the pendant light. In dining area we can't have fan because we have this pendant, so I can't give fan. Even if I give a fan, the blades might interfere with the lighting, so I have not given fan here. This only works on this AC. Okay, this is the common area, indoor. This is common area, nothing much here. Now here for the TV I have given provision as such. So these are 3 switches, 3 sockets, 3 switches, 3 sockets. And you might say, why are you giving 2 modular socket? That means 3 pin sockets. These are 3 pin sockets. These 3 are 3 pin sockets. You can give 2 pin sockets. Yeah, I can give 2 pin sockets, but nowadays even the charger is so thick that it only goes into the 3 pin socket. So there is no point in giving 2 pin sockets, because the client will be unsatisfied. So this is cove, and these are the profiles. This is the drawing room. So this is the position of our main DB. That is this DB. So this is not a guesswork. This is not at all by no way is this a guesswork. This is a purely engineering work, and I am a competent person with a valid license and a certificate of competency to do this kind of work. So this door will open like this. This will open towards this side. Main DB is here. Okay, then here I will place 1 switchboard, calling bell and all that. Okay, and this bar area needs some more provision. See this, there will be a I will tell you about this bar area. So basically, this is the main switchboard which is controlling the bar area. Okay, this is for the downlights as usual. Then this is for the AC blowing the air. The AC is blowing the air like that. Okay, and this one we have drawn it to the trapdoor. We have placed the driver here. See, the trapdoor is also serving this AC. So this is proper engineering. From here we are drawing the DC lines to these coves. Okay, and one more switch I have given as a spare, and one blank, two blanks. Okay, and on this table I have this painting just for representation purpose. I have kept it like that. This one, we'll move it. Okay, let us assume this is not there. I have given two plugs here, two plugs and two switches. This is to charge the cell phone and all that, and the wire comes from here, here, and we will route it like this, and we'll give two power 16 amp sockets here or under this, because this might be doors. Suppose these are doors. If I open the door, I will place a freezer chest for the wine bottles or the beer. So there will be two freezers. Okay, even for that we have given the electrical provision. There is this is the provision. Okay, this is on B phase. This is this phase separation. This is all engineering work. This is highly technical work, and so not everybody will understand this, but this is the bread and butter of what we do. See, this is in a blue phase. This is yellow phase. If it is yellow, it is Y phase. Blue phase, R phase. We have three phase in electrical engineering in India: R, Y, B, red, yellow, blue. So we try to divide our loads on all three phases so that the load is balanced. And here for the curtain, again there are two motors, because there is a curtain here. They might want to show off. Guest will be sitting here, so they want to show off their house. So they will obviously have a pelmet and a curtain motor here. Automation, they will definitely go for automation. So this is the wall on which they will hang their TV. They will do some woodwork here. They will place a profile under the cabinet, grazing lights and all that, painting, all that. So for that sake, I have given for that, did I give anything? Yes. For that I gave one more switch and a blank. So this is the way we do lighting design for a house. Basically one room we do, and basically it is the same thing for all. Okay, if you're an architect and you are doing your own work, then you can consult us. I mean, we do different kinds of work. We only give you the lighting points from DIALux, or if you want us to give lighting points and just the boxes here, you don't want us to give all this detailed information, we only want to know where the switch boxes are, we can give you that. We charge a different price for those. And if you want us to do a full blown hardcore engineering work, then this is the scale of our work. This is the scale of our work. So this is our main job. This is our main job, where we say on which MCB, what load is coming on which MCB, what wattage, is it complying with the NEC, National Electrical Code. Then we also, this is all our loads, this is all the connected load for this house. You see, so many equipments are there. Okay, then once we do that, we will go with this. Then after that, we separate it phase wise and we see if it is complying with our codes of India. 1 point, 10 points, 10 points, 2 points, what is the wattage, which phase is it coming, connected load, what is the amperage, what is the amperage that it might draw under normal operation conditions at full load. This is it might draw current that is less than or equal to this under normal operation condition. If there is any abnormality, then it will go above. That is again the domain of electrical engineering. What wiring has to be used, why it has to be used, what is the diversity factor, why this is there, then what is the demand factor after that, what is the demand factor after that, what is the contracted load for the client. This is our, so this is my job. See, R phase load 16,702 watts, Y phase 16,673 watts, B phase 16,813 watts. Mean, what is the mean? So how much deviation is there? See, only 83 watts, 56 watts, 27 watts. That means 0.16%, 0.34%, 0.5%. But what does the government of India say, electrical department say about these deviations? 5% is applicable, is permissible. What 5%? This is not even 1%, not even hardly 0.5% is there. That is a master stroke of our engineering. So this is the total connected load. This is the demand factor. So the client will take this and he will say, I need a 32 kilowatt contracted load. So your contracted load will be this. Your contracted load will be this. And yeah, that is. Then there is a short circuit analysis. Then there is a short circuit analysis. It is very important. It is very important, circuit analysis. Again, if you want us to do a full-fledged project, then we take up this kind of work. Or if you want you just want us to give you a lighting layout. I will show you one thing. If you appoint an electrician, if you get your work done by an electrician, he will not know what is this thing. 6,000. Can you use this for this project? I know it will fail, and I know what value has to be used. It all comes down to short circuit analysis. So basically you take the rating of your transformer, and then from that you calculate the impedance, and on that you will get the short circuit currents. On that you get the short circuit current. So if you go with your electrician, if you are on a budget, then there is no option. If you then that is the only way. But you can, if you can afford for an engineering service, then you better go with an engineering service like this. So this is rated for 400 volts. What is this? When will you use this? And can you use this in a residential building in India? This cannot be used. Why? I know why it can't be used, but so it is like there is much to these circuit breakers and all that than just this 63 C rating. Okay, C is for inductive loads. That much okay, you understand, but again, so this is the main MCCB, molded case circuit breaker, which is the main incomer. Parallel bus. This is for my house. This is for the house, and this is for this VRF, the outdoor VRF which I have. This goes to the VRF. That means there are wires from here, 5-core wire. Okay, you do one thing. You take a 4-core wire, 6 square mm 4-core wire, and one earth wire you draw. One earth wire you take, 2.5 square mm earth you can take. From here you can take it and you can drop it in this isolator. You drop it in this isolator, and from this isolator you can operate your VRF. You can operate your VRF from here. And this is for this is R1, R2, R3, R4, R5, R6, Y1, Y2, Y3, B1, B2, B3. These are okay. This is 2-pole RCCB, 40 amps, for 40 amps RCCB, because if there is any electrical shock, we don't want to have any emergency. We want the circuits to trip. So that is the reason we have used this per phase isolation PPI dB, not a regular dB, taking safety into consideration. And those circuits, they just drop in here. So R1, so basically this is coming from R1. This is R3, this is R3, and this is R3. So a typical electrician might be confused. So we do have electricians with us who are competent to do this kind of work. There is one R3 here, there is one R3 here. Okay. Okay. If you avail our service like this for a detailed drawing, it is better to hire our own electrician, in-house electrician, who can do this kind of work, because typically the general electricians outside, they will not be able to understand, and we have a limited time, so we can't spend lots of time explaining them. So the electricians who are tied up with us, they can understand what we mean, and he will know what to do and how to do. In fact, after this we sit with them and we decide the routing of this piping and all that. We say that this is the line and this is the thing. Based on that, we come up with a workable plan, and then we execute the project. If it's a double bedroom, then there will be a single phase. So for single phase, there is no phase separation and all that. So it is very less complex. So an electrician can take it up. But for 3-phase, it has to be balanced. Or most importantly, if you are constructing a builder house for 3 floors or 4 floors building, and you are installing a small transformer, then it is very mandatory that you get this analysis done. If you don't get this analysis done, what will happen? Your transformer will trip. One phase will always be losing power. Two phases will be on, one phase will lose the power. The one which has maximum load, that will always trip. So it is very crucial. This is not an option. If you are building a builder house or a big project or a big villa, a luxurious villa where the electrical load is high, or if you are building a multi-floor tower, high-rise tower, then it is a must that you have to get these kind of analysis done. And even the regulating authority needs to see this, that is your load balanced. Okay, then per circuit they will check each and every circuit, each and every sub circuit they will check B1, how many points are there, what is the load, everything will be checked by the competent authority. So that is, if it is a double bedroom, then it's okay. If it's a small house, double bedroom where you will buy in an apartment. So the apartment, the apartment guy, he does it and he sells. So this is the thing. So this is the short circuit analysis. This is how we do short circuit analysis, and this is how we do it. So again, this is an engineering service. So it will cost you dear, but again there are various variants. If you want such a thorough analysis for your project, you can get it done, or you want to simply get a DIALux analysis done and few lighting points. I won't recommend that, but people tend to do it. But as an engineer, I don't recommend doing that kind of thing. If you get it done, then it is better to get it done properly, because house is going to last for at least 60 years. So it is better to hire an engineer and get your circuits